So here's another really fun paper that I did. The theory that's here is that gamma ray bursts have contributions that come from nuclear criticality events. Now, that might sound weird. Maybe you don't even know what a gamma ray burst is. We know that outer space, we see these big pulses of gamma ray bursts that occur intermittently throughout time. And this paper showed how the effects of gamma ray bursts are indistinguishable from inadvertent criticality events. And you might say, well, how are you having a nuclear criticality event? That's basically where you're having fission taking place in a burst fashion. Basically, the material will fission, it will go critical, and then it will expand from heat and go subcritical. And the reason why that looks like a gamma ray burst is because the energy distribution of prompt fission, while it's going fission, looks like the front end, it's indistinguishable from that front end of a gamma ray burst for most of them. And then the tail, as the gamma ray burst is tailing off, the energy distribution of that tail looks like delayed fission or fission product decay. And even the time profile for that is the same as fission product decay. So the energy of the leading edge, the energy of the tailing edge, and then the shape of the tailing edge are the same. And then often what happens with terrestrial criticality accidents is that you get pulsing. The system will expand, and then it will go subcritical, and then it comes back together. Say if it's in a container, it goes critical again and keeps happening until it uses up the fuel. And this is the same thing that would happen in an accretion disk. If I had fissionable material, say that would come from a black hole and a neutron star merger, or a neutron star merger, where material comes together and then tendrils get whipped off and flinged out into outer space, creating the transuranics. For example, where we believe they came from in the Earth, those transuranics, while they're out in outer space, if they got condensed in an accretion disk, which, for example, would have occurred for the creation of the Earth, then the fission process could again occur because you're going to have a lot more fissionable material early on. Say, for example, the uranium in the Earth at the time of the Earth's formation, it would have been high enriched uranium rather than trace amounts of uranium-235 and uranium-238. And so this paper shows how that could have occurred and is still occurring today out in outer space, that nuclear criticality events are occurring and contributing to the gamma ray bursts that we see. So it was really fun. I know that the editor said that I was very contrarian with this because it's not the standard model that astrophysicists use to describe gamma ray bursts, but it's really fun. I'll put a link in there, and it's just consistent with all the measurements that you see, and you don't need anything really fancy other than just standard, very well understood physical mechanisms. So hopefully you like that. Hopefully you think this is cool. I sure did. It's fun to think about those kinds of things, and I guess it just shows what kind of a nerd I am. So thanks for watching. Have a good day. Bye.